Alright, so here's the answer to the question that you sent. All worked out for you. Let's go through how I got here. I took the unit that I was given, in this case 1 mile, and I said, how do I get that to centimeters? What dimensional analysis does is it uses a trick in multiplication, where I can cancel things out as I go along by multiplication. We all agree that like some fraction a over a is the same thing as 1. And that's going to be the rule we end up using today. So if a over a is 1, I don't know why this isn't erased very quickly, then I can say, well, miles times 1 over miles, that these are going to end up canceling because it's going to be the same thing as mile divided by mile, which has to be 1. Now to get there, I have to say, well, what's equal to 1 mile that I can, to make that conversion? How can I get 1 mile to be in the denominator if miles in the numerator in the term first? And of course I'm going to do that by converting to feet in this case. So I say 5,280 feet are equal to 1 mile, and that's what my fraction here says. And well, feet aren't centimeters. They're not what I'm looking for. So I need to use another term and say, how do I get rid of feet? And of course I can say, well, I don't know a lot, but I do know there are 12 inches in a foot. And so I set it up and say 12 inches are in 1 foot. That way when I multiply through this whole chain of things, these feet will cancel. 1 foot in the numerator, 1 foot in the denominator, foot divided by foot is 1. Now the 5,280, it stays alone, right? It's not a unit, it's just a number. Inches aren't where I'm going, but I know the conversion factor between inches and centimeters. And so I set that up again, where inches are in my numerator, inches are in my denominator, and I can cancel it. Now I go through the problem and I say, okay, I have a 1 here, but mile, there's no mile here anymore because it's canceled. 1 times 5,280, feet have canceled, so they don't matter, times 12, it's just a number again because inches have canceled, and times 2.54, and my centimeters, they're still left. So my units have gone to be all these numbers times each other, and I put centimeters on the end. This is how I know I've done it right. If I go through the whole problem of multiplication and division, and I get the unit I'm looking for, the number's right. That's the trick of dimensional analysis. The only hard thing is knowing which number to put in the numerator and which number to put in the denominator. So if you ever get stuck, always know that you're trying to get rid of something, and kind of think it along those lines. So let's say I'm trying to get rid of, let's just come up with something like 2 meters per second, a speed. Alright, and I want to convert this into something like maybe meters per hour. 2 meters an hour. I don't know why we're going to do that, but I can. I take my 2 meters per second. Let's see, I'm going to keep meters, but I need to get rid of seconds. So I know, for instance, there are 60 seconds in 1 minute. Mr. Nidek, why did you put seconds on top, not on bottom? Because when I multiply through, these seconds are going to cancel. Now, I'm not looking for minutes, I'm looking for hours. So of course I need to say the same thing. 60 minutes per hour. And of course I can come through and say, well, minutes cancel. Then I get my 2 times my 60 times my 60. And of course, my speed in meters per second becomes, 7,200 meter an hour, 7.2 kilometers an hour. So you can see that that's going to work out for us too. Because of course when I multiply it through, my meters stay the same. All the other units cancel out. I'm left with an hour in this denominator here. So I get 2 times the numbers to get 7,200. Meters is the top of my unit, hour in the bottom. Cool.